ಅಷ್ಟೇ ಹಾಕ್ತಾ ಇದ್ದೀನಿ.
Hello everyone. Good evening.
Good evening, sir.
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 Yeah, good.
Good evening, sir.
Yes, let me share my screen. Okay. So how was quiz? How was the exam?
It's easy. After the answer key released, I feel like yeah, it's tricky.
Mm, Okay. Uh, Others?
It was moderately good, sir.
Okay.
Like above average, but okay, okay.
Okay. It was
The
tough.
question paper is, sir, almost moderate to below average, we can say, but in some questions there is some traps.
Okay. Sure. Okay. So, but I think it was very straightforward.
Sir, will you explain one question in the question paper, sir?
Mm, I can, but okay. So let so hold your doubts. I mean, why I'm telling you that because there will be. I think we can take one session where not today, where we can discuss the question paper itself, the whole question paper. So if you have, because one or two question is not a problem, but if whole question paper is a issue, like many questions are there, then it will take up more time.
Okay, sir, thank you.
Uh, so okay, so we'll cover not combination, just permutation is there. Okay, so we'll cover what is, I mean, what is permutation. Before permutation, uh, so why do we need this thing is it will help us later on in probability. So when we'll compute probabilities, we will require it. Okay, and why do we need probabilities? Because till now, like week 1 to 4, we only did kind of summarization of data, try to understand what is there in data and compute values. But we didn't do anything which requires kind of making conclusions or something. So when we later on try to make conclusions, there is a chance related to it that it might happen, might not happen. Let's say, will from the data, can you say will rain happen tomorrow? It might happen, it might not happen, right? So you can say that maybe 60% chance that it will happen. Rain might happen tomorrow based on data, or how many customers will come tomorrow into the mall. If you have mall data, you might predict that okay, this many people can come up tomorrow. Okay, so there is a chance now going to come into the picture. So to study chance, we need probability. To understand probability, first we need to understand permutation and combination, which will help in finding probabilities. Okay, so uh, so we have what is counting principle. Okay, which is like what is um what is addition rule in that, then what is multiplication rule. Okay, then we have permutation itself. So permutation, in that we have when all the objects are distinct. Okay, so when like distinct objects are there, uh, objects are there, when all are not distinct, but some are repeating itself, right? So um, maybe I can say not distinct. So distinct means different, like different you can say. Okay, so let's say A, B, and C are different, but A, B, here A is repeating, right? So repetition here, you might say repetition. Okay, so then what if there is a circular pattern, right? So we'll look if there is circular pattern. Circular pattern. Then in circular we have, what if the clockwise and anti-clockwise both are same, right? So um, clockwise and anti-clockwise same. Okay. So this all things we'll cover today. So let's see. So let's say you have um, let's say you have four boxes, okay, A, B, C, and D, right? So if I tell you you have to select, or you have to pick one, right? How will you do that? Um, so you can say, maybe, I can select A and not any of them, or you can select B and not any of the rest, right? C, likewise, like C, and likewise D, right? So basically you can choose four ways, right? So four ways to select a box, right? Same way, let's say you have different kind of thing. Let's say you have boxes C and D, uh, and you have, let's say, circles, okay? Um, let's say P, Q, and R, like circles and boxes, okay? So if I tell you that you have to select one box, and so and yeah, so four ways, and that is what addition rule is kind of, that you have four distinct things here, and you want to select them, right? So either you can choose A, or B, or C, or D, right? So that's how you get four numbers, that 1 plus 1 plus 1 plus 1 equal to 4. This is what addition rule is. Um, okay. So let's say you have now A, B, C, D, P, Q, R, and something like that. Now if I tell you that you can choose any one, okay, again same question, that any one you have to choose out of this seven things, right? So how many ways you can choose? You can choose either A, right, and not any of this, okay, because you can choose one only. Let's say you can choose B and not any of this, right? Same way you will go for all of them, and what you will get, either you can choose four of this or three of this, right? So you'll get seven, correct? Seven ways to choose out of this seven thing, one item. Then same thing, if the same amount of things I had, let's say A, B, C, D, say, so if I tell you that you can choose one box, okay, one box, and one circle, say, okay. Uh, if I tell you that, then what will you do? You can choose any of this, right? So let's say you have to choose both of them, but like one of each, okay? So you can choose A box, and let's say P of that, right? Circle, or you can choose same box, but different circle, and same thing you can do with uh, again R circle, right? So three circles are there, and each of them you can select with A, right? So A box and P, Q, or R, any of them circle. Same thing you can do with B also, right? So
Sir,
yes,
hello?
yes,
Sir, your voice is little bit lower, and
okay.
it's
Perfect,
not
sir.
clear enough, sir.
No, no, bro. It's okay, sir. It's audible.
Yes, yes. Give me a minute.
So we are not able to hear you. And we can see you, sir.
Hello. Is my voice okay now?
Sir,
And now it's
yes,
okay,
It's
sir.
okay, sir.
Okay. Share my screen again. Okay. Okay, so I was explaining that you have 4 boxes and 3 circles. Okay, and you have to choose one box and one circle, right? So and is important here. So what we can do is I can choose for first box A, let's say, and I can choose with having A again like P, Q, or R, right? Any of them. And same thing I can do with B also. So let's say I choose B box and I choose P circle, then B box again and Q circle.
To
So
always, right, sir? Multiplication rule.
yeah, this is multiplication, right? So same way you can do for C and D, right? And you will realize that how many we had, like 3 here, 3 here, 3 here, and 3 here, which is uh, 12, right? So how did I get 12 from this? So this 4, this 4 into 3, right, which is also 12. So that's what multiplication rule is. So to be tell you very easily that whenever you see or, that do something with or, do addition. Okay, wherever you see or, do addition. Whenever you see and, do multiplication. Okay. So let's say if I tell you that there is from A station to B station, you can go with 5 ways. Okay. So you can see, right? So you can go with, let's say, first way, or either you go with this first path, or you can go with second path, or you can go with third, or you can go with fourth, or you can go with fifth, right? So that's how we get addition, right? So addition is or. Okay. If if let's say I tell you that from A to B, um, you can go, let's say, in between a stop is there. Okay, C stop is there. Okay. So you can go with A to C in several ways. Let's say 4 ways, and then from C to B you can go with, let's say 3 ways. Okay. Now, um, now see what I have to do is I have to go from A to C, and I have to go C to B, right? And so you can see and is coming, like I can't stop here. I have to go from A to B. Okay, that is the task, that I have to go from A to B. I have to go from A to B. That is the task. So I can't stop at C. So I have to go from A to C, since there is no direct route from A to B. Okay. Uh, so first I'll go from A to C, and then I'll go C to B, right? So here I'll use multiplication rule. So how many ways I can go from A to C? 4 ways. And how many ways I can go from C to B? 3 ways. So that's how I'll get 12. Okay. Okay. So that was about addition and multiplication rule. And so this will use when you can see OR being used, and here AND is being used. Okay. Now sometimes what happens is, like here we had, like we had no choice. Like let's say A, if I choose this route, then of course I can't choose another route, right? Uh, but sometimes, let's say, another type of questions where you can have repetitions also. So for example, let's say you have um, there's a 3-digit lock. Okay, 3-digit lock is there. Okay. Now let's say here you can choose any number between 0 to 9. Here also you can choose any number between 0 to 9. Here also you can choose any number between 0 to 9, right? So how many numbers you can create out of this? How many different kind of password you can create of this lock, right? So this is a 3-numbered lock, and anything can come in between, right? 0 to 9. So we can see that here we can have 10 numbers, right? 0 to 9. Okay. Here also we can have 0 to 9. And here also we can have 0 to 9, right? So here repetition is allowed. So that's why I'm again using multiplication rule only, but uh, uh, but here options are not getting, less after selection, right? So it will stay same. So I'll get 10 into 10 into 10, which is 1000. And you can see from 0 to 999, if in digits, if I tell you that you can choose any number, right? So that is also 1000 type of numbers, right? Okay. Okay. Now let's see. Uh, okay. Uh, so let's say uh, we have four people. Okay, four people. Say P1, P2, P3, and P4. These four people are there, and they race. They start racing, and I have to choose who will win the race. Okay, that's what the thinking is, that who will win this race. So you can see that, maybe P1 can win the race, right? Or maybe P2 can win the race. There's P3 can win the race, or P4 can win the race. So here also it's addition rule, right? That four ways it can happen, right? But now that was I was choosing one person, right? One person, that who will win the race. Now if I ask you in what order, so now I'm talking about order. Okay, in what order a race can happen, right? So let's say P1 wins, then so now I'm ordering him. So like who will come first, who will come second, who will come third, and who will come fourth, right? So this is got ordering it. So it might happen that P1 can come first, right? Then P2 came second, say P3 came third, and P4 came fourth. Or another way is, let's say P1 came first. If uh, P2 came second, but P4 came third, right? In a race, the fourth person came third, um, and then third person came last, right? So this can also happen. Then same way you can write, um, let's say P3 comes second, P2 comes second, third, and then fourth, right? And such you can write many ways. And what will it be, right? So that is the question. So that is the question. So we can, instead of writing all of the different types, that how many ways this can happen, what we can do is we can think, right? Because the question is not to write that uh, in what order will happen, right? Write all the orders. But the question is how many ways or how many orders can take place, right? So we can, if we think mathematically, so you can see that any of the 4 people, anyone can come first, right? Anyone can and anyone can come first. But since whoever came first, he can't be second, right? He can't be second. So how many people can come second? 3 people, right? 3 people. Out of 3, anyone can come second. So now first and second both places are taken. So only 2 people left, right? Only 2 people has to race to come third, right? So third position will be taken by any of the 2. Then whoever is left will take the last place, right? And one left, right? So 4 people started it. So that's a 4. Then whoever came first, any of them, like P1, P2, P3, or P4, any of them.
Sir, here no repetition are allowed, na?
No, because it's a race, right? Persons are there, so a
Hmm.
person can't be repeated, right?
Hmm.
He can't go back and run again
Okay, sir,
or
got it.
something like that, right? So yes, so like this, right? Then anyone who came first here, let's say P1 came first, then he can't race for the second position. Those who are left, they have to run for it.
So is it
That-
n factorial?
Yes, it's going to be that only. So and so on, right? So how will you do is you'll multiply this, right? Because that's what end rule is. That anyone can come first, and somebody will come second position, and somebody will come third and fourth, right? So you have to multiply 4 into 3 into 2 into 1, which is going to be 12 into 2, which is 24, right? So 24 ways are there so that this race can happen, right? 24 ways in this race can happen. Okay, so here 4 were there. Maybe you might be you might try and write it down, but when you have, let's say, 10 people racing it, right? 10 people are there who are racing. Then if I tell you how many ways this race can happen, then it will become difficult, right? Because you can't write them. But what you can do is you can maybe think that, okay, first position can be taken by um, any of the 10 participants. Then 9, 8, 7, 6, 5, 4, 3, 2, and 1, right? This way you can write all of them. So whatever multiplication will come out, even I don't know, but that will be the number of ways this race can happen, right? So this way of writing is called factorial. So if we define factorial is being written like this, like so any integer, okay, very specific, that no, like nothing else, only integer should be there. I'm calling it as n, okay. So you'll write like the n and then this exclamation mark, okay. So n factorial, this being take like n factorial, okay. And n factorial is n into n minus 1 into n minus 2 and so on till
Go on.
1, okay. So here what I wrote is this is 10 factorial, okay. This whole thing, this box is 10 factorial. Earlier what we did is this is 4 factorial, okay. Okay, so let's say what is 3 factorial? 3 factorial is going to be 3, then you can say n minus 1, right? So 3 minus 1 is 2, then n minus 1. So we reached at last, right? So 1 is the minimum value in this, which is going to be 6. Okay, what is going to 4 factorial? You can write 4 into 3 into 2 into 1, which is 24. 5 factorial is going to be same way if you do. So maybe you can do 5 into 4 factorial also, right? You know that this value will come up, and if you know 4 factorial, you can directly multiply with 5, right? And you'll get 120, correct? Same thing you can do with 6 factorial also, that's 6 into 120. So what is this? 720 something, right? So you can maybe take help if you know a prior factorial, then you just need to multiply one number with it. If it is easy multiplication. Otherwise, you have to use calculator or something. Okay?
Sir, why 0 factorial equal to 1, sir?
Yes, so 0 factorial is equal to 1. So, okay, so think in this way that, so when where this factorial is coming up is, later on you will see that it's in the permutation, okay. So permutation, number of ways this race can happen, right? Let's say here I told you that how many ways a race can happen, right? Something. Uh, but that is also possible that this race cannot happen. Say that this race cannot happen. Something happened and this race didn't happen. So that's why we call zero factorial as one. Okay, so zero factorial means this race didn't even happen at all. Something like that. Okay. Or you can think that say we have to when we do arrangement or something, right? Let's say A, B, C are there. If I tell you to arrange them, okay, arrange them. So how many ways you can arrange them? So they are in linear order, okay, linear order. So let's say there are three objects, right? Three objects. So you will realize that it will be going to be 3 factorial. So if I write you A B C, A C B, then the B A C, B C A, C A B, C B A, right? So 3 factorial is 6, right? So 6 ways to order them in this, right? What if you have 0 items, like you have nothing, like empty something, right? But you can have that as 1, right? I mean nothing is a 1, okay? That this is also a possibility. So that's why we give it as 1, okay? But if something takes place, let's say 1 takes place, then nothing cannot happen, right? So that's why both have 1. Like 1 factorial is also 1, 0 factorial is also 1. Okay, both are 1. So either it's there, it's not there. If it's there, then it could be more also, right? More than 1. But if nothing is there, that is only one possibility. Nothing was there. Okay. Uh, okay. So this is what factorial is. Okay. Now, now let's see what is there is. So let's say if I give you something like 6 factorial by 3 factorial, what could be this? Okay. You want to figure it out. Then you know that I since I did here that we have 6 and then
120.
here you can see 5 into 4 factorial, right? Or something. So I can write 6 into 5 factorial, right? This thing. And
720.
and then you know that 5 factorial is also 5 into 4 factorial. And also 4 is also 4 into 3 factorial, right? And
Like
division is also by,
3 into 3.
can you mute yourself? You can see I can write this thing in 6 into 5 into 4 to 3 factorial, right? And then I can remove them. So division, right? So you will get 6 into 5, 30 into 4, 120.
120.
Same way you can do more also. Let's say you have 6 factorial into 5 factorial divided by 3 factorial into 4 factorial, right? So if you want to do this, you can maybe
600
write,
will come.
yeah, so 6 into, so
6
I
into
can
5 into 4 into 3.
so I can write 6 into 5 into 4 factorial, and let's say 5 into 4 into 3 factorial, right? Then we have 3 factorial and 4 factorial in division, and we can cut them off, right? And we'll get 6 into 5 into 5 into 4, right? So which is going to be this is 30, this is 20. So
600.
20 into 30 is
600.
600. Okay? So 600 can be there. So same way you can do, let's say any numbers are there, you can definitely do it, right? So say 8 factorial by 4 factorial. You can write 8 into 7 into 6 into 5 divide by, so into 4 factorial divide by 4 factorial. You can cut off and you can multiply them. Okay? So it will come handy when we'll do permutation, because permutation
Sir, I have
for,
one question, sir.
yes,
Sir, can you please show us the process of converting 7 into 6 by 4 into 3 into factorial terms
7 into 6.
by 4 into 3.
Uh, where? Here.
No, no, no. Please express 7 into 6 by 4 into 3 in terms of factorial. मतलब digit से
Uh,
factorial में.
he's asking about previous slide, sir. Fourth slide. Yeah, that's fine.
No, 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 no. That's not. That's one. From just integer to factorial.
Integer to factorial. Uh, so, okay. So, oh, what is this integer about? Is it
No,
this
not that one. Can you please solve it for?
for? Okay. Tell me what do I have to solve?
At first, like 7 into 6
Okay, 7 into 6.
by
Okay.
4 into 3.
4 into 3. Okay.
Convert these terms into factorial.
You want to convert them into factorial.
Yeah.
Uh, okay. So let's say 7. Okay. So whatever you want to do, you have to when you do multiply, you have to divide same amount with denominator also, right? So what you can do is you can maybe do 4 into 3 into 2 into 1. Same thing you can do here as well. 4 into 3 into 2 into 1. Okay. So both ways I multiply. So above you will get 7 factorial. Denominator you can get
The
this as 4
sir.
factorial into 4 into 3,
The
right?
pi is missing.
Sorry.
The pi is missing, sir. Numerator pi is missing.
Yeah, okay. 5 into 4. Okay. So then I have to multiply 5. Sorry. Then I have to multiply 5 into 4 into 3 2 into 1. So that will be 5 factorial, right? Okay. What else I can do is I can do let's say I can multiply here 2 into 1 and at numerator also 2 into 1. So that will give me, so 7 factorial divided by 5 factorial I had this 2 and this 4 terms will make it 4 factorial, and 2 into 1 is 2 factorial. So that's how you can do it. 7 factorial into 2 factorial divided by 5 factorial into 4 factorial. You can have it in different ways also. So maybe you could have let's say 7 into 6 were there and 4 into 3 were there. You could have done um, say if I multiply both of them, mm, then I would have got 4 factorial. Uh, okay. Or what if I try to get 6 factorial at the top? Okay, so I had 7. What if I try to get for that point? No. I mean you can get it, but okay, let's be settled with this. Okay. Uh,
Okay, sir.
okay. You can write in several ways also.
Yeah, sir. Got it, sir.
So
You can proceed further, sir.
okay. Okay, so you can see that we use this factorial at everywhere, right? So here I did it when we were choosing 4 persons are there, they race and who will win, right? So uh, so that's what uh, that's what we can do. Now let's see some, we can take a question. Say you have word BIRT, right? So how many ways you can arrange them? So question is how many ways you can arrange these letters of this word. Okay, and meaning doesn't, it should not be there, or be there doesn't matter. Okay, it should, if it's not meaningful, then it will also work. So we just have to arrange these letters. So how many ways we can do that of the bird? So we can do that with like BIRD one itself. Then maybe I can write BIDR and so on. If I write all of them, it is going to be 4 factorial. Okay, and how do I know? See, I know because let's say first position anyone can come, right? Either B can come, I can come, R or D, right? At first position, uh, or let's say I have 4 positions and anyone can come here, right? And whoever comes here, it can't be at the second position. So I can have 3 only. Rest of the 3, right? Whoever got selected there will be rejected at the second position. Then third position, some 2 will be left and then 1, right? So that's how I know that it is going to be 4 factorial. Okay. You can maybe see that, let's say I have word cat, it's cat. Can actually write all of them. So CAT can happen, CTA can happen, ACT can happen, ATC can happen, TAC, TCA, right? So 6 ways are there, and I can solve like this also, that any 3 can come up here, then rest of the 2 and then 1, right? So this is 3 factorial, which is 6. Okay. So okay, so till now we had very distinct people, distinct letters and all. But what if you have something like, let's say, DAD, right? So you want to arrange them. Then what will you do? So you can see, let's say if I write DAD, right?
Sir,
If I
is
write,
3 factorial by 2 factorial because 2 are repeat.
yeah. So let's say if I write DDA, uh, okay, what else I can do is, can we write ADD, right? Uh, this 3 ways I can think. So okay, so if let's say all were different, maybe I can have D1 and D2. Let's say D1 A D2, D1 D2 A, then A D1 D2 A D, then maybe D2 D1 A, right? So this 6 ways I can actually write. That's what I did with cat. So you can see I wrote all of them, and similar way I'm writing here as well, right? But you can see, since D1 and D2 are actually same, right? So this is the actual word, but actually D is repeating itself, right? So you can see that, where is it? D1 at start, and you can see this one and this are same. Okay. Um, Same thing here also, right? So this are also same, this also same, and you can see this 2 are also same, right? Itself, correct? And you can maybe write DAT, ADD, and here DDA, right? DDA. So these 3 things are unique in this. And so how did we come up with this is, so if we have, let's say, n distinct object, and in that anything is repeating, so here we have only one, right? So maybe I'll call it as P. So you have to divide by that factorial. Okay. So 3 factorial by 2 factorial, and that's how we got 3 into 2 factorial by,
Sir, can't we tell the formula like n factorial by n minus 1 factorial?
n minus, no, that's not the formula. So let me uh let me take, let's say, another.
Sir, 1 second, can I say how that P1 has to?
Okay. So give me a minute. Okay. So let's say you have n objects. Okay, n objects are there, out of which P1 are of same type. Okay, out of n. Okay, same type. P2 are of same type, and P3 are of same type, and so on. Okay, so we have, let's say, Pk of same type, and so yes. Okay, so you can say maybe P1 of same type. I mean, how many numbers are there? So they should sum up to n. Okay, so it's not like here you can say, so P1 is D. Okay, so D was P. Uh, Maybe you can take this type of same type. So T were P1 type or something. Okay, okay. So to explain this formula, uh, if you have this kind of setup, that n objects are there, out of which P1 are of same type, P2 of same type, and so on as till k of same type, right? Then how will you find the permutation is? If they were all different type, then you know that you can do with n factorial ways you can arrange them, right? But if they are repeating, then you will write maybe P1, you will divide by P1 factorial, then P2 factorial, then so on till P of k factorial. Okay. Okay. Uh, so same thing we did here. So we only had one type of same element. Or maybe you if you want, you can maybe write P2 as well. So let's say we had DAD. Okay. So I have two types of element here, A and D. This is appearing one, this is appearing two only, two times, right? So what I can do is I can write n factorial by P1 factorial, P2 factorial for our case. So n is 3. 3 factorial by P1 is 1 factorial, P2 is 2 factorial. And same thing you'll get 3, right? 3 ways you can arrange them. So here comes the permutation formula. The permutation is, let's say you have n distinct objects, right? So also all are different. Okay, nothing is um nothing is repeating again. Then how will
Sir,
you?
I have one question, sir.
Okay.
Sir, I couldn't understand that P1 and P2, how it is 1 factorial and 2 factorial.
Uh, okay, so
Means
don't worry. So
A is 1 and D is 2, that I understood. But how it is 1 factorial, 2 factorial, that is coming.
okay, okay. Let's see first permutation. I think I should have gone through with this part. So okay. So first see, we have, let's say, n objects. Okay, and then all of them are distinct. Okay, nothing is repeating or anything. So how will you? If I tell you to choose, let's say, R object of that, not choose. Okay, arrange R object of that. Okay, arrange R object. You have n distinct object and you have to arrange R object. How will you do that is, that
NPR.
is NPR, right? So n factorial divided by n minus R factorial. Okay. Okay, I think I need to prove.
Sir, is R objects or repetitive, sir?
No, because there is no, I mean, you can't, how, see, we have objects are itself distinct, right? So you can't repeat them anywhere. I mean, object also can't, whatever you select also can't be repeated, right? So this is the only thing from which you have to select. Let's say you go into class where 40 students are there, okay, and you want to arrange them, okay, 40 students, or maybe, out of them, maybe you have 10 students who you want to arrange, okay. So how will you do that? Uh, all are different, right? They can't come again. I mean, anyone, if you choose or something, then it can't happen again, right? So that's not a possibility when we have distinct objects. Yeah.
Okay, sir. Thank you.
Yeah. So okay, somebody has said that why is it like this, right? Uh, so to be frankly speaking, that's how the formula works. That whatever you have, and then how many different ways, different groups are there, so which are like similar kind of objects. You have to divide them by factorial as well. So that's how you can get the number of ways. Okay. So you can maybe think that this is the formula and you have to apply it like this. Okay? There is no, I mean, like, there is no proof for this. Okay, that how this is coming. Uh, you can think that this is how it is. Okay. So let's say you have word statistics, right? So if I tell you how many ways you can arrange the letters of this word, how will you do it? So first you have to write what are of same type, right? So let's say S is here it's appearing, and then here and here, right? So 3 times S is appearing, and T is appearing 1, 2, 3. Okay, again 3. A is appearing 1 only. Then okay, T I already included. I appearing twice. Then C is there, which which is appearing 1, right? So 2, 3 plus 3, 6 plus 7, 7 plus 2, 9, and 1, 10. And you can count here as well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So 10. Here you can sum them. I included all of the distinct letters in my calculation. Okay. So 10 objects are there. Now, so question is how many ways we can arrange them, right? So first, so we'll go with formula that n factorial divided by p1 factorial, p2 factorial, p3, and so on. Okay. So 10 factorial, that's what n is. N is 10. And then I have to write all of them, right? So 3 factorial, 3 factorial, 1 factorial, 2 factorial, and 1 factorial. Okay. So what will you get? You'll get, maybe 10 into 9 into 8 to 7 to 6 to 5 into 4. Then I can remove one of this. Okay. And 3 factorial is actually 6. Um, 2 factorial is 2 itself. 1 factor is 1, 1. You can remove this guy and 2. So the answer is going to be 10 into 9 into 8 into 7 into 5 into 2. Okay, so whatever this calculation is, that many ways you can arrange this letter. Okay,
100, sir.
yeah, whatever. Okay, so let's say you have letter coffee. Okay, coffee is there. How many ways to arrange the letters of this word? So you have to count, right? So C is appearing once, O is appearing once, F is appearing 2 times, then E is appearing also 2 times. Okay, so how many ways you can arrange them? N factorial, which is 6 factorial, then 1 factorial, 1 factorial, 2 factorial, and 2 factorial. Okay, so you can see this is 4. Okay, 6 into 5 to 4 to 3 to 2 to 1 and divide by, let's say, 2 into 2, right? 2 factorial is 2 itself. So we can remove this and we'll have 30 into 6, which is 1.
180.
Okay, so if you have any other
What happens when repetition is not allowed?
repetition is not there, so there is not. Okay, so if you have, let's say, word like let's say mouse, then what will you do? You'll do directly n factorial. Okay, because even if you do, let's say, 1 factorial, 1 factorial, 1 factorial, 1 factorial, and 1 factorial, will it change anything? No, this is just 1, right? So you'll get 5 factorial, which is 120.
Same thing applies to the coffee.
Applies to,
The previous example.
yeah, all the examples, anything.
Okay. Okay.
Okay. Okay. So if you have n items, n distinct items, you have to choose r items. You'll do npr. This is permutation. Okay, which is n factorial divided by n minus r factorial. Okay. Yes. And okay, you have to not choose. You have to arrange r item. Okay. Arrangement is where permutation will be used. And we call it as permutation only. So the number permutation of n objects or r objects out of n is this way, right? So whenever you heard like arrange word, choose permutation. Okay, whenever you hear word choose, later on it will come, so that is combination. Okay, wherever it's like, okay, and if I tell you something, so let's say you have um, distinct objects, right? Let's say 5 distinct objects are there. Then you'll write 5 p what, all of them. I'm keeping all of them and arranging them, right? So if I do that, you'll get 5 factorial divided by 5 minus 5 factorial, correct? And 0 factorial is 1. So ultimately you'll get 5 factorial. Okay, so whenever you have distinct objects, all of them are distinct, and you are arranging all of them, then you can directly choose 5 factorial case. Okay, directly write 5 factorial. You don't need to do this. Whatever the 5 objects are there, arrange them. Then you don't need to go through this formula. You can directly let 5 factorial. Okay, so okay. Okay, so I'll just let's say choose, and let's say choose and arrange. Okay. This three things are there which will come into the questions. Okay. So I'll just introduce combination little bit here, and you'll know. So when we have some distinct objects, let's say R distinct objects are there. Okay, R distinct objects. We can arrange them in R factorial base. Right? Arrange. We have to arrange them, right? R distinct objects. Now, now if I tell you that what is choose is combination, right? So let's say you have n objects. Out of them, you have to choose R objects. Okay, choose R object. So what will you do? You will use combination, which is the formula is in combination n factorial by n minus R factorial
Into R factorial.
into R factorial, right? So this is combination. Now if I tell you to do choose and arrange, okay, so you know how to choose from this, you know it, right? This is what combination is. So you can choose this way, n minus R factorial into R factorial. So same thing, n objects, choose R. Okay. Now whatever you chosen, right? R objects you chose already. If I tell you to arrange them, how will you do it? That also you know, right? But in between end is there. So what will you do when end is there? You add or
Sir, in
multiply.
choice, what is C, sir?
C is combination. So like P we use for permutation. Here, okay, this is nothing.
Yes, sir.
Yeah, this is nothing. Just
Okay, sir.
formula
Okay.
is this much.
Okay.
If and is there, we have multiple guys.
Multiplication, right? And you know to do R factorial base. So what will you get? You'll get this get cancelled. You'll get n factorial by n minus R factorial. And what is this? This is NPR.
NPR.
Okay. So whenever arrange is there, just all the distinct objects, and you can arrange them in R factorial base. You can choose them out of n R objects by NCR, and you can choose and arrange using NPR. Okay. So that's how this permutation combination works. I mean, whenever you get a question, so you have to think, what is it? Is it choosing? Is it just arranging? Is it choosing and arranging? Or sometimes what happens, you have to do choose or arrange. Okay, so there is no formula for that, but you know that how to do both of them separately, and you know what to do when or is there. So you add them. Okay, so choose them, then add them.
Sir,
Okay.
if we have to arrange n objects are there and we have to arrange R objects, n factorial by n minus R factorial, that's it.
You have to arrange n objects.
In n objects, we have to arrange R objects arranged, sir, in n distinct objects.
Yes, you have to arrange, because whatever you chose, right, that only you can arrange. So let's take an example. Let's say you have 30 students, okay, in a class. 30 students in a class. For a uh, for a competition, any 10 can be selected. Okay, for a competition, any 10 can be selected. Okay. Now, how many ways can they be selected? Now that is the question. Okay, how many ways they can be selected? So first is I have to choose some 10, right? Any 10 I have to choose, and let's say okay, no, for a competition, yeah, and any 10 can be selected, and for a competition any 10. Wait.
Can be chosen also.
Any 10 can participate. Okay, and 10 can participate. How many ways? How many ways a competition can happen? Can happen, right? So this is the question. This actually, uh, so first you have to choose 10 people, right? So 10 students out of this. So how will you do? You will choose 10 people, but whoever got chosen, they can participate, right? And anyone can happen means who will win or something, like who will rank wise. You have to rank them. Okay, so 10 are there, so anyone can come out of these ranks, 9 and 10, right? So these are the ranks in which you have to arrange them, right? So that you can do with 10 factorial ways. Okay, so that's how this is NPR actually, that is 30 factorial by 30 minus 10 factorial by 20 factorial. Okay, uh, so whenever you have to choose and arrange, that's where permutation is being used.
Then, sir, hello? Hello?
Yes, yes.
Sir, if we want to choose out of 30 student, 10 student and arrange them in 10 factorial ways.
No. Then
10
see,
ways.
uh, so if let's say you have 30 students
Hmm.
and you're saying I chose 15 first,
Hmm. And arrange
right?
them in 15 ways.
Then you have to arrange all of them, right? Whatever you selected, then you have to arrange all of them, because all of them can get some position, right? Some position in a competition. So like this. Okay. Then you will arrange them in 15 factorial ways and choose. This is choosing part. NC, so 30C 15. Okay. So choosing is like this, arranging is this way, and when you have to do both, that is permutation. So you can see NCR into R factorial, which is NPR.
So, sir, we can say uh, NPR equal to NCR by R factorial.
No, into R factorial. And so this is arrange, and this is choosing. Choose and arrange is permutation. Okay. Like I told you here.
But if we derive from formula, then
That's what I did, right? That's how you will get NPR. You have to multiply only. You can remove. See here, I removed R factorial, factorial. So this is NCR formula. How to choose some object. Okay.
Sir,
Yes.
sir, can you explain that question? Yes, sir.
So we had 30 students. Out of that, any 10 can participate in the competition. Okay. And how
Yes,
many
sir.
ways this competition can happen? So we have to give ranks to all of them. Okay. So whoever the 10 student got selected, they get ranks, right? So let's see first the 10 part. So we had 10 students, right? Or say 10, 5, 6, 7, 8, 9, and 10, right? So 10 positions are there and we have to rank them, right? So first student, so whoever the 10 students are, out of them, anyone can come first, right? Anyone can come first. Anyone can come second? No. Whoever left, they can come second, right? So
9.
nine only. 8 can come third. 7, 6, 5, 4, 3, 2, 1. So what is this? 10 factorial, right? So
Yes,
this
sir.
is arrangement. I did arrangement, right? So this
After
way I can arrange.
choosing from the 30, you are ranking them.
Yes. So out of 30, I chose 10 first, right? So that
Yes,
is
sir.
using combination. So
Yes, sir.
I use 30. So 30 factorial by
30
30
minus
minus
10
10 factorial and
into 10
10.
factorial.
Okay. So this is whatever you get. Okay. like this. So this way you can arrange and choose and arrange. Choose and arrange. And you know that whenever and is there, you have to do multiplication. So choosing is this way, and then 10 factorial, which you will get 30 PR or P10. Same thing.
But in
Okay.
you have said right, sir. If arrange appears, it is a combination, and choose appears, it is a combination.
No. Arrange.
Yeah.
So arrange is when you have this object size. Some you can do this factorial ways, R factorial ways. Choose you can do this way. When you choose and arrange, then you have to use permutation. So arrangement itself is a permutation. It's a part of permutation. Why is that? See, you have 5 objects. Okay, you have 5 objects. If you want to arrange all of them, how will you do it? 5p 5. What you will get? 5 factorial divided by 5 minus 5 factorial, right?
Yes.
And this is 5 factorial. Okay. So arrangement itself. So here what I'm doing, I'm choosing all of them. Okay, you can say choose all or something like that, and then arranging. Okay, so this uh, uh this part is getting 1 here. Okay, choosing part. Only one way I can choose all of them. So let's say I have 5 students. Okay, 5 students. E. If I tell you to select all of them, select all of them. How will you do it? One way only, right? Only because all of them you have to select. There's no other way.
NCN.
No, choosing. Choosing. How will you do choose? How will you choose 5 students out of 5 students?
IC5.
Okay. So if you do that, what will you get? 5 factorial divided by 5 factorial
5 minus
into 0 factorial.
0 factorial.
So this is 1. Or you can say only one way to do it, right? So you can see, right? I have to choose all of them, right? Only one way I can choose all of them.
Sir, if the elements are same, it affect the arranging. Will it affect the choosing also?
Yes, it does it. Uh, it's little different, okay? But generally, we don't go into that. I mean, we don't have to go into that for this course.
Okay, sir.
Okay. So that was choosing and arranging. Okay. So this NPR is when repetition is not allowed. Okay. Repetition not allowed. If there's many permutations, you can get. Okay. Yes, so repetition not allowed, then you will use NPR. But what if repetition is allowed? Repetition allowed. So what will you do? So the question is same. Like let's say you have this 3-numbered log, okay, and anything in between 0 to 9 can come up here. Okay. So anything you can write, and as we did, like you can choose 10, any of the 10 digit, 10 into 10 into 10, and you'll get 10 power 3, right? So same thing you can maybe write. So if repetition is allowed and you have n distinct objects, so uh, So I mean, see, whatever I do here, any number I choose, I have to again choose it here, right? So that's how it's distinct in this case. That whatever I do, it doesn't mean that I don't do it again here, right? And repetition is allowed. So how will I do is I will do n into n into n. The repetition is allowed. So n power r, or in this case 3. So this is the formula basically. So if it is happening for r times, like repetition is happening r times, or, or I have to uh, mm, yeah, or I have to arrange so the number of possible permutation of r objects from collection of so possible permutation of r objects from collection of n distinct object object when repetition is allowed. Okay, so when repetition is allowed, so what you will do is we'll do uh, n into n into n r times. Okay, so this is rth time, and you will get n power, okay, like this. So 10 power 3 we got because 3 times we can do. Okay. For example, let's say you have ABC, 3 objects are there. You can how many ways you can arrange them? Possible arrangement you have to write where repetition is allowed. So previously, when it was not allowed, what we did? We did
Sorry, sir.
3
3
factorial,
factorial, n
right?
factorial.
6.
Okay.
If we had ABC and possible arrangement. So if repetition was allowed, then what can I do? I can choose A at first position, again A, and again A, right? So same way I can do A B also. I can do A B A, right? And so on. So how many ways I can do is, so there are uh, three distinct objects are there. Three distinct objects from n distinct objects. So in this case, 3 are there. And how many times I have to do it? 3 times, which is going to be 27. Okay, so let's say you have just A and B, then maybe we can write also, which you will get 2 power 2, 4 ways, right? So A A B B A and B B, right? So this 4 ways you can arrange them. No other arrangement is possible. Okay, we are just arranging. We are not choosing here. Okay. So now last part of this is circular arrangement. How to do circular arrangement. Okay. So let's see. So we had, let's say, A, B, C. Okay, and uh, I want to arrange them. And in linear fashion, when I did, what I did is I wrote A B C, A C B, then let's say B A C, B C A, C A B, C B A, right? 6 factorial ways I can do it, right? So this was in linear order. So order was linear. Like I didn't put them in circles. But what if I put them in circles? Then what will happen? So let's do it. Let's say I have this circle, and if I wrote A here, say A B C, right? So they are in circle. Okay. Now, now if I start rating from here, let's say like this, so ABC, which is this, right? ABC. What if I start from B? If I start from here, then BCA. Can I see BCA here? Yes, it's here, right? BCA. Then let's say if I start rating from C, CAB. Can I see CAB somewhere? Yeah, CAB also here, right? So guess what? I can ABC, BCA, and CAB. This all three of them are in one pattern only now, right? They are not different. Uh, uh, Correct? This just looks they are in similar order, but this three kind of permutation which were possible previously when they were in linear order, now they are not possible because this all three are same, right? In a circle they become same. Okay, is it okay?
So,
Yes, sir.
Okay, so what is another possible way of this? What if I write
clockwise direction.
A C B? Okay. Is it different from ABC? Are they different or same?
Same.
They are different.
Different, sir.
Okay, because you can see you can read like this. What you'll get? So I'm reading in clockwise only. Okay. A
Sir, we can't
uh,
take in anti-clockwise.
you can do that, but so if you say that both anti-clockwise and clockwise same, then there is different thing. So uh, you always have to read them one direction. But if it is being mentioned that it's clockwise and anti-clockwise same, then it's different. So we generally see them in one direction, like clockwise. In this case, we are looking at clockwise.
Okay, sir.
Okay. So I'm looking them clockwise only. So that's why it's a different. So here C is coming first, then B is appearing. Okay. So you can see this is the arrangement ACB, and if I start reading on C, then I'll get CBA, which is this one. So this one. Okay. This is another arrangement, and then I'll get another arrangement is if I start reading from B, right? So BAC from here. Okay. So
Sir, is the formula is n factorial by 2?
no. Uh, uh, okay. So how do we make formula of this is, so formula of this is n minus 1 factorial. Okay. So previously you were able to arrange them in n factorial ways. Now you will be able to arrange them in n minus 1 factorial ways if they are in circular order. Okay. So you can see three objects are there. 3 minus 1, which is 2 factorial, and which is 2. So this two ways we can order them. Okay. Now if it's given that clockwise and anti-clockwise is same if it's being told that, so you can see that here um here I'm reading clockwise, both of them, but if I start reading them anti-clockwise as well, then they both will become same, right? They both will become same. So then I'll get only one arrangement. So how will I write a formula for this is n minus 1 factorial divided by 2. Okay, because there are two directions, so that's why 2 is coming up. That two, both of them are same, right? So I would divide them by 2. So if you do, let's say you have A, B, C, and D. Okay, and you want to do them in circular order. and clockwise and anti-clockwise same. So how will you do that? You will write n minus 1 factorial first, so which is 4 minus 1 factorial. Then you have to do division by 2. So you'll get 3 factorial by 2, which is 6 by 2 t. Right? So 3 ways you can do that. So maybe we can write also what 3 ways are there. So let's see. So we can write A, B, C, and T. Okay. Now, what are the possible ways? Okay. What are the ways? A is there. What if it starts with C, B, D? Okay, so yes, right. So if I write from after A, D can't come in any way, right? So once A has appeared, then I can't write D again, since clockwise and anti-clockwise both are same. That's what I being told. A, B, C, D this way also. Okay. One more possibility is
Sir, we can write B in upside.
no. See, we have to always start from one object. So because we have to arrange all of them, right? Anyhow. So if you start writing any other object, then you'll never reach there. You think it's different, but it's not different.
Okay,
So
sir. Okay.
to start with A, then think of something else.
Sir,
What
then B can be in right side. Which is, sorry, in left side.
in left?
Yes. There. Yes, sir.
Then what should I write here?
Sir, there you can write C.
Okay, no,
You
that
can write D, sir.
will be same
You
as
can write
this.
D.
Okay,
D
yes,
can
sir.
write.
D. Yes, sir. D.
And write D here.
D
Then
also.
A, B, okay, A, B, yes, A, B, nowhere it's appear, and C, yes. So this is another way. Okay, so there's 3 ways
Yes, sir.
possibility. C, A, B, D, okay, A, C, B, yes, right. So it should A, B, C, D, A, C, B, C. So they are not. So they all are distinct. Okay. So you can write, maybe you can think clockwise. At least if they are distinct, then is it anti-clockwise also distinct? I mean, this 3, okay, this 3 are anti-clockwise also distinct, and you can see all 3 of them are distinct. Okay.
Sir, what if there are only two elements, sir? If A, comma B, if that formula can exist, n minus 1 factorial by 2.
So if we have 2 elements,
Yeah, sir. A, B should be one way. Either
yes,
clockwise or clockwise. Is that
yes,
formula
yes.
applicable or not, sir?
So you are saying 2 minus 1 factorial, then divide by 2, is it?
Yeah, sir. Yes, sir.
Okay. So let's see. You have this 2 objects A and B. Okay. Now you are saying anti-clockwise and clockwise same,
Yes, sir.
right? So does it make sense to do it here? I mean, formula is okay, but we don't do it here, right? I mean, we don't need to do it because there are 2 elements
So
only. So if
practically we know that is a one way, but theoretically that formula of type we didn't get any. It doesn't make any sense. Right?
yes, I mean, theoretically it doesn't make sense, but we don't need to use it here. So we will never have this kind of condition, and we'll use like this, right? That what if anti-clockwise and clockwise same, because it's already same thing, right? I mean, you put A B or B A or whatever, so there is no actually arrangement happening here. Nothing you can do in this. Is there any permutation happening here? Like, is there any permutation? Is there any different kind of thing happening here?
There will be zero factorial one way. That
No,
A
one
B
is
should
happening,
one way.
right? At least one way is there. A B. I
Yeah,
mean,
yeah.
so
One
one
way.
factorial is possible, but
Yes.
But is there any different thing or anything? Is there any different thing happening here? So
Count, count,
it's like
addition count rules, sir.
addition,
Addition count
which
rules, sir.
I didn't get you.
Addition count rules, sir.
Sorry.
Addition count rules, sir.
Yeah. So what about that? Can you? I mean, what is addition?
Uh, 1 plus 1, 2. So,
No, 1 plus 1. No, there is no need of addition or multiplication for now.
okay, sir.
Sir, and my another doubt was, sir, what if can we assume that there is a repetition is allowed in such circular cases, sir?
Repetition is allowed
Without,
or not. So it depends
yeah,
on the
yeah.
question. If it is allowed, so but here repetition is we have n distinct objects. So here we don't have repetitions. No, repetition is not
So
allowed. Yeah,
repetition
repetition
means
is not.
not suggested. If there are four places around the circle in the parameter of this allowing parameter of the circle. In those four places, can we place a such like
Yeah, yes, you can do that. So that is a different thing. So but here repetition is not allowed. If you do all of them A, that is one way only.
yeah,
One
it
way. There
is
is
it not considerable, sir? Is it not considerable
for what?
for finding number of ways that those elements can be permutated
If
along
if
with
repetition is allowed.
yeah,
Um,
for-
it could be there, but it's not there for us.
yeah,
For
okay.
us, it's not there. For in this course, it's not there. So for us, like repetition, not allowed cases are there.
Yeah.
Hmm, okay. Yes. So that was all about permutation. Okay. Mm, see it again too.
So sir, that's it for today.
Yes, yes. I'm just looking if I'm not missing something, but I
Sir,
think I covered.
can you go through some good numericals now from your end?
Okay.
Hello,
Yes.
sir. Is there any more other than you cover topics in week 5, sir? Because I don't feel
No, that's not only. So addition rule,
through
multiplication rule.
That's all for week 5, sir.
Yes, yes, permutation only.
Yeah, okay.
Okay. Okay, so let's say a student has 4 history books, okay, 3 math books, 2 say let's say geography books. Okay, he wants to arrange uh, all of them such that each subject book appears each subject books appear together. Okay, so this is the question. How will you do it? Here's 4 history books. Okay, so let's say H1, H2, H3, H4. He has 3 maths book, let's say like this, and 4 geography books. Okay, so sorry, 2 geography books, 2 geography, 4 history, and 3 mathematics. Okay, so something like this books are there, and he wants to arrange them in such a way that they should appear together. Okay, all of them like this. They should appear like this only. So how will you do this? In linear order. Arrange them in like so. Order is linear only. Okay. So first,
So
what will you
9
do?
factorial.
Okay, 9 factorial. Then is there something I do? So in 9 factorial, this is also possible, right? Let's say H1. Okay, so first position taken by H1. Okay, in 9 factorial. So 9
Yes.
into 8. 9 into 8, right? So 8 means anyone can come up here. So M1 also appears here. M2 can appear here. But is it possible? Is it possible in according to our condition that that each subject books appear together, right? So each subject, so this is history, math, and geography. They should appear together only as a bundle. Like they can't anyone can't come in between, right? So that's not possible. 9 factorial is not the right answer. Okay, anything else?
Sir, NPR. That formula.
Okay. So what is R?
Sir, is it 3?
Okay, so NP3. I mean 9
Ah.
9P3.
Yes, sir, 9P3.
Okay. What is going to be that? 9 factorial
9
by
factorial by
6 factorial.
9. Yes, sir.
Yeah, and so this is going to be 9 into 8 into 7. Okay. Okay, whatever. I don't know. Might come out right also.
Sir, I have a doubt, sir. If you use this formula, then that should be that it should be no, sir. But we have
Sir,
4
please
times
scroll down.
history book and 3 times max book and 2 times geographical book. So
They are
it's
distinct
not
only.
possible, sir.
Every book is distinct, but each subject book should appear once. Okay, so
Okay, sir.
okay.
So don't we write like this? So 9 factorial by 4 factorial into 3 factorial into 2 factorial.
Is there anything repeating in this case?
No, sir.
No, right? So this was when we have repetition. I mean repetition, or yes, repetition was there, right? Some later was repeating or not distinct, right? So when not distinct case was there, then we did this. So that's why it's wrong. This is if I have 9 books and I want to choose 3 books. Oh, sorry, I want to choose 7 and arrange 3 books only. Okay, so if you, that's why I told you what is choosing also. So if you see this is choosing 3 books and arranging 3 books. Am I arranging 3 books only? No, I want to arrange all of them. So that's why this is also not going to be right answer. Okay.
N factorial by P factorial. With that formula, can we do this?
And factorial by
P factorial.
2 factorial.
This is 2.
2, right? 2. That's what I wrote. 2.
Sir, P factorial. I mean, the repeated objects. Number of repeated objects.
There is no repetition. All are distinct. All
Okay,
books
sir.
are distinct. They belong to one subject.
9 factorial by 6 factorial into 3 factorial.
By 6 factorial.
And 9 factorial is multiplied by 4 factorial into 3 factorial into 2 factorial.
9 factorial is
In the
multiplied
numerator,
into
yes.
9 factorial by what?
Numerator is 9 factorial into 4 factorial into 3 factorial into 2, sir.
4 factorial into 2 factorial, or 2
Into 3 factorial.
into 3 factorial.
Yes.
Okay, so 9 will be there. Huh?
And denominator is the same, sir. 6 factorial by into 6 factorial into 3 factorial.
3 factorial. Okay. I'm not sure about that. Okay. Is there any guesses, or should I answer?
4 factorial plus 3 factorial plus uh, 2 factorial.
Okay. Okay. Let's see. Okay, any other guesses?
So I have one question.
Mm-hmm.
1 by n minus 4 factorial.
1 by
n minus 4 factorial equal to 20 by n minus 2 factorial. In this case, I am if I solve the quadratic at the end, I am getting n equal to 7 and n equal to minus 2. Which value I have to choose?
only positive integer is possible, because this is reality, right? I mean, negative number is not possible. Minimum is 0. This is positive integers, or
Sir,
non-negative
or else,
integers.
sir, like 9 factorial by 6 factorial and 3 factorial
9 factorial
divided by 6 factorial and 3 factorial.
3 factorial. Okay, so this is same as NC. This is same as 9C
Is
3.
3.
Okay, no, that's also okay. Let's see. Okay, I'll solve. First C.
92.
Sir,
Okay, should I solve?
92, sir.
What? 92.
92. 9. Permutation 2.
9P2.
Yes, sir.
No. Okay. Okay, let's see. Okay, how to do that. Fine. I'll start. Okay. So first we have, let's say, 4 history books. Okay. 3, 4. How many ways I can arrange them?
4 factorial.
4 factorial.
4 by 3.
4 factorial only, right? 4 factorial is I can arrange them. Okay. Is it okay? Now, how many
Yes,
ways?
sir.
I have math books, right?
3 factorial.
How many ways I can arrange them? Okay.
3.
Now I have geography books. How many ways I can
2
arrange them?
factorial.
2
2
factorial.
factorial, right? Now let's say I call this as H1, H. I call this as M, call this G. How many ways I can arrange them?
3
These 3
factorial.
things.
3 factorial.
3
3
factorial.
factorial.
So what I'm doing actually, first I'm doing arranging each of them, right? So 4 factorial, and also I'm arranging, so 4 factorial, I'm arranging history books, and I'm arranging math books, and I'm arranging geography books, and I'm arranging all of them, like 3 groups, right? So 3 groups also I'm arranging. So this is the answer. Okay. So whatever this
Okay,
comes up,
sir.
you first have to arrange them, and see, we saw that how to arrange distinct objects, right? A, B, C, let's say 3 factorial. You can say that one group is a distinct object, but inside that also arrangement is happening. So this, like, inside arrangement is also happening, and here we have different kind of thing, right? So what is this? This is 24 into 6 into 2 into 6. We'll get, what will
294.
we get 1728. Okay. Okay, so now let's see. So we have, let's say, statistics. Okay. We want to arrange them in such a way that vowel should appear together. Together. Should appear together. Okay, so this is what you have to do. So you know what is vowel? Anybody who doesn't know vowel?
No.
Okay, fine, right? So how will you do this?
First, select the vowels and place them anywhere. Means stack them together, group them together, and then you can place them.
Okay. Okay, so I'll group them, right? So what I have? So this is a vowel. This is a vowel. This is a vowel. Okay, fine. So
Well,
3
I
vowels are,
think so, sir.
yes.
So 6 factorial by 2 factorial, 3 factorial, 1 factorial into 3 factorial by 1 factorial, 2 factorial into 9 factorial. Am I right, sir?
I'm not sure. This is too much. Okay, we'll see. Whatever your
So,
answer is. You can.
okay, sir. Okay, sir. 6
So
factorial. Okay, sir.
okay.
Like we can say like 10p3.
No. See, why P3 will not come? See, whenever you see, we have to arrange all of them. Okay, you should not use permutation, like permutation formula. Why? Why is it? Because what is it? You are actually choosing 3 elements and then arranging 3 elements. That's what permutation means. Am I choosing any numbers? No, I'm choosing all of them, right? So I need all of them. Something related to factorial should be there. Okay, just factorial will be required, nothing else. Now, how will I use factorials? That is the case I have to do, right? So something I have to do with factorial. Okay, so let's say if I had just statistics and vowels or something I didn't care about, then what I would have done is I I would have first wrote like what is um, repeating objects, right? So S is appearing, let's say, 3 times, right? And T is appearing 3 times. Then A is appearing, I guess, 1. Okay. I is appearing 2 times. Okay. And then C is appearing once, right? So And then so this is general case when no condition were given to me. So then I would have been able to arrange them in whatever. So 3 plus 6, 7, 9 and 10. 10 factorial by 3 factorial, 3 factorial, 1 factorial, 2 factorial, 1 factorial. So whatever this answer comes up, that many way I should have done it. But now out of this, okay, some will be there where they are clubbed together or vowels are appearing together. So that cases I have to find from this. Okay, so it can't go above this. Okay, it should be less than this. Okay, somehow. Okay, let's see how to do that. So what I'm saying is vowels should appear together. Okay, so let's see. So what I need is I need st. Let's say t, s, t, c, and s. Okay, and then a, I appearing together. Okay, so this is the arrangement I want. Now, see what can be the possibilities. So let me tell you, SAII, right? So this group is coming here. Then not anything can do. Anything can happen here, right? Or let's say a group is appearing here, and then something, right? So any of these possibilities are there. Okay. So let's see how many ways to do this. Let's see first that, and then how to do that. Or let's not do that. First, let's do the subgroup part. Okay, this subgroup part is how many ways to arrange them. So what is it? 3 factorial by 2 factorial. Correct? Correct? Okay. Now see, this is this group repeating again? No, right? This group is unique. Am I correct? This group is unique. Like you can maybe just call this group as G. Okay, so let's say S G T T S T C S, something like, right? So this first you can write like this. So G is appearing once only, right? There is no repetition of that G. Now what we have to do is we have to maybe write answer for this. Okay, so how many ways we can arrange them? So how many times S is appearing? Okay, how many elements are there? 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. So 8 factorial. Okay, then S is appearing 1, 2, 3.
3
3
times.
factorial.
3 times.
G is appearing one times. So I'll just write T
3 times.
appearing
3
3 times.
factorial.
Then C is appearing one time, right? So what we get is 8 factorial by 3 factorial into 3 factorial. Okay, and so this part, don't mess it out. We have this multiply by 3. Okay, because internally also they can arrange, right? So what we get? 8 factorial by 3 into 2 into 3 into 2, and then can maybe remove 1, 3, 2, right? So something like this you will get. So this is 8 into 7 into 6 into 5 into 4, 2, 2, then 3 into 2, 2. So this can go away, this can go away, and we'll have 8 into 7 into 5, 4 into 3. Okay, so this is the answer. Fine. So this is how you'll do when they are appearing together or something like that question is there. So think one group as a one entity. Okay, so till now we saw distinct object, right? So distinct object can look a club of few objects also. Okay,
So why we have multiplied?
Sir, 1 minute, can you show
this?
upside, sir?
multiplication, because and, right? This and that should happen, right? It's not or. That's why I said when you use and, you have to multiply. So this will happen internally also, right? It's not like this can happen or that can happen. No, this will happen inside only.
But sir, there is only two entities, so why we have taken the three?
No, there are three, right? A, I.
Acha,
These
acha,
three
okay.
vowels are there.
Okay, sir, got it.
So you multiplied 3 because there is 3 vowels, so that's the reason, sir.
No, not that. See, if three vowels were there and they were distinct, then I would have multiplied by 3 factors. That is 6. But I did by 2 because I is repeating again, right? So when repetition happens, what you do? You divide by
Sir,
that
thank
number.
you, sir. Thank you.
Sir, once again say why you multiplied with 3.
So, okay. See, first, see what we did here, this case, we individually figured out how many permutation happens here, right? Then here, then we multiply all of them, correct? So that same way you will do here. So here, see, when I wrote G, inside G, this three ways can happen, right? Inside G, any of this.
Yes, sir.
So that also have to multiply, right?
Okay, sir. Okay.
No, let's say okay. So is it okay? Okay, so let's take another question.
Sir, thank you.
So let's say you have 20 students in a class. Okay. You want to choose captain and vice captain. Captain and vice captain. How many ways you can do that? Hmm?
Sir, 20C2.
Okay, yeah, I think it's okay. Combination question, correct. No. Um, so to explain this easily, what you can do is, so first, see, anybody can become captain, right? Out of 20, and who are left, he will become captain, vice captain, right? So 20 into 19, whatever this is, 20C2 P2. Okay. So easily it's being done like this, correct? So anybody can become captain, but whoever becomes captain, he can't become vice captain. So out of 19, somebody will become vice captain, right? So now let's say again, let's say 20 students are there, in which let's say 12 boys were there, 8 girls are there. How many ways? So a group is formed out of this, okay, of 5 students, in which 3 boys are there and 2 girls are there. How will you do that?
Sir, in
This
previous
is
question,
becoming combination question. Wait, this is a combination question. Let's not do this. Yes.
here, why can't we take 20C2? Means if we are taking 2 students from whole 20.
No, I'm not saying we can't. I that could. So what is 20C2? 20 factorial by 20. Okay, what is it? 20 minus 2, right? 18 factorial by into 2 factorial, which is going to be 20 into 219 by 2. Okay, so no, right? No. That is not the case. It is just 20 into 19. So no, this is not a combination. This is a permutation. It's a permutation only, right? So 20p2. You can see 20 factorial by 20 minus 2 factorial, which is 18 factorial. You will get 20 into 19. Correct? So this is 20p2.
Okay, sir, got it.
Okay. Like we
Sir,
did with
also find whether it is permutation or a combination.
so generally when choosing is there, just choosing, that is combination. Okay. So when you do choosing as well as arranging and arrange, that is permutation. So basically you have to be careful that is it just choosing or do I have to do choosing as well as arranging also. So arrangement will happen when some order is given, right? So let's say here captain vice captain order was given, or rank is there where ordering can happen, or something like that, right? So whenever we talk about orders, then you should know that permutation will come up, otherwise it will not come. Okay. Okay. So let's do one last question, something related to permutation. Let's say 10 students are there. In how many ways uh, they can sit in a row such that uh, such that uh, such that three students, okay, some three students are there, three students always come together. So some out of 10 students, let's say S1, S2, S10, maybe you can take, let's say S1, S2, S3 should always come together. Okay, so how will you do this? Okay. Any guesses?
Like we have done in
8 factorial into 3
statistics.
Sorry, like we did with statistics, right? So yes, almost same. So how many elements will be there? 8. 8 factorial by sorry, 8 factorial into 3 factorial.
3 factorial.
So this what answer will be. Okay. Okay. So yeah, that's all for today. Okay. So whatever this answer is.
So, could you please just elaborate the last question one more time?
So, okay, so there are 10 students are there. Okay. And you wanted at least, you wanted 3 students to sit together. Okay. Some 3 students. How will
Okay.
you do that? So you will form a group of that. Okay. So if you form a
Yes,
group
sir.
of that, so one group is there, and then let's say S4, S5, S6, 7, 8, S9, and S10. So how many are there now? 8, right? 8 distinct objects. So how will you arrange them? 8 factorial ways, right? 8
Yes, sir.
objects, 8 factorial. Then, but this S1, S2, S3 should come together. It's not like they should come in this order only. They can come anywhere, right? So let's say S1, S1, S2, S3, S1, S3, S2 also possible, and same way, right? So 3 factorial ways possible in that also. So that's why 8 factorial and 3 factorial.
Yes, sir.
Okay. So that's all for today class. Okay, bye then.